Hello. This time I want to show you how to subdivide a surface. This is an exercise useful for as first step in paneling management, and we should start directly in Rhinoceros this time. So go to the Curve Tools palette in Rhinoceros, select Curve Interpolate Points, and draw a curve. To close it, just go to the starting point and click on it, so you can have a closed curve. Now go to Grasshopper, select Params Curve, right click in the middle of the component, select Set One Curve, and click on this curve. So now we have a copy of this curve inside the Grasshopper. Now select Boundary Surface. You can find it under Surface Freeform Boundary Surface. Connect the curve with the boundary surface, and now you have the surface inside the curve. You have to remember always that the domain of this surface is a square domain, so we need a mathematical function under maths divide two-dimensional domain. We can get this component that generates subdomains from an original mathematical domain. The U and V parameter are the inputs for the subdivision. Connect the surface with the I input. Now, if we activate a panel, you can find it under Params Input Panel, we can see a series of domains, of subdomains. Now we are going to use this subdivision with another component that is named isotrim that generate the tiles. You can find it under Surface Utilities Isotrim. Connect the boundary surface with the S input and subdivide domain to the D input. As you can see, this component divide the mathematical domain that is square, that is a rectangle. So the surface inside the curve is actually a trimmed surface. So to obtain just the tiles inside the curve, or the pieces of the tiles inside the curve, we can start using a component named Prep Edges that you can find under Surface Analysis Prep Edges. As you can see, now we have the boundaries of the tiles separated in segments. Each one of these branches has the 4 segments of one tile. And we need to rejoin this segment to obtain the continuous rectangle. a closed polyline. So use the join component. You can find it under curve utilities, join curve. Connect the edges output with join curve. And if we connect the output of join curve with the panel, we can see that the segments have been converted to in a polyline curve. Now to generate the boundaries of the elements inside the curve, we need an intersection, a shape region intersection component. You can find it under intersection, shape, region intersection. So, connect the joined curve, the polylines, to the A plug, and the first curve of this algorithm to the B plug. As you can see in this icon, the curve generated by this component are just the ones that are shared by the curves in A plug and in the B plug. So just the curve inside this boundary. Now, if we connect the output of this component to a panel, we can see that some branches are empty, and these branches relates to the tiles outside the curve. Now, if we connect the output of this intersection component to a boundary surface, we get just the tiles inside.